No, I can't imagine it's changed that much from.
Terrains are an essential element of 3D games, especially for massive open-world games. We can quickly design and build stunning environments and landscapes for players to explore. In this series, we're going to look at the terrain tools in Unity. I will summarize some of the tips and tricks when building terrains, and I will introduce some of the tools to make your development easier. There are multiple ways to design terrains. We can use external tools like modeling software, map generators to generate height maps and meshes, or we can even use algorithms to procedurally generate terrain meshes. But in this course, we're only going to focus on building terrains using the built-in free. Here I'm introducing the
Plan.
terms vertex, triangle, and mesh. There's a strong relationship between the three. A vertex is a point in the virtual world. Each vertex contains a positional data, which is often expressed as a vector 3. When three vertices join together, they form a triangle. When one or more triangles join together, they form a mesh. A terrain mesh is initially a flat mesh, spanning in the x and z direction. When we edit the terrain using the terrain tools, we are basically adjusting the heights of the vertices in the y direction. The system then renders the terrain mesh based on the new vertex data, resulting in a beautiful 3D landscape. In Unity, when we use the built-in terrain tools to edit terrains, the data is saved as file assets. We can replicate multiple terrains with the exact same shape. That is an introduction to how terrain works and the terrain meshes. In the next video, we are going to set up the environment and to actually explore the different features provided in the terrain tools. I'm Yellow Flicker and I will see you in the next video. Stay tuned.
I'm not so sure about this tutorial.
Welcome back to the Unity Terrain Basics series, in which I will talk about the
It looks
basic
good though.
techniques.
Alright, what I need to do is I need to fix this collision box. It is not good. What I can do is actually change the cat. Does this have a no? I mean, honestly, it should just match whatever the X is here. It doesn't. Actually, if I zero it, that doesn't match for whatever reason. Okay, so we need to adjust that. It's fine. All right. So what we need to do first off is we need to freeze. So y-axis. I wish that didn't scroll so fast. I forget what we have to do to sort that out. Now we can zero it out? No. Still on the ground. That's whatever though. Like, let's not play this in maximized. Play that in focus. What's the rotation? The Z rotation, probably. So what happens if we freeze the Z rotation? Freeze all of it. All the rotation. Just won't have any. It's not necessarily ideal. So the Y. What's the Y rotation? Okay, let's freeze the Y. Freeze, unfreeze the Z. Okay, so that's like the rotation. Yep. Yeah, we definitely want to freeze the Z rotation. So that's like the rotation, this X. Okay, so if we unfreeze the X, should be able to do this. See what happens when we get funky. Some really funky terrain. What I could do is I could technically limit the amount in a script, limit the rotation of the. See, that shouldn't be. Well, I guess it is moving because. Then like reset. I think I'm not even on the thing anymore. Yeah, that's just something I'll have to figure out.
Of designing terrains in Unity using the built-in terrain editor. In this video, we are going to set up the environment, then we are going to look at 3 of the most basic scoping features. Let's begin. Let's begin setting up the environment. There's a package provided by Unity which offers additional features for terrain editing. Let's go ahead and install it. Go to Toolbar, Window, Package Manager, and from the drop-down at the top left corner, select Unity Registry.
It's a little different, but
And from the search box, we can type Terrain Tools. In this series, we will be covering the additional features provided by this Terrain Tools package.
Terrain tools unlock is installed as part of a 3D world building feature. Download asset samples. Oh, it literally. Okay. Sure. That's going to take a long time. Even though it's 2 gigs, it shouldn't take that long. Okay. What we're gonna do is we're gonna try this.
Let's hit install and wait for it to complete.
Terrain tools.
With the Terrain Tools package installed, we can begin creating a terrain. To create a terrain, simply right-click on the Hierarchy tab, select 3D Object, Terrain. This will create a terrain mesh as well as a terrain data file, which can be accessed in the Project tab. Selecting the terrain object in a hierarchy, and in the inspector we will see 2 components, the terrain and the terrain collider. The terrain collider will automatically adapt to the shape of the terrain mesh and provide collision between other objects and the terrain mesh. And now we will look at the terrain component. As you can see, there are 5 tabs. We will discover each of them shortly. At this point, we will first look at the terrain settings. There are numerous configurations. We will focus on the mesh resolution.
Really? This right here. Because this is massive.
In this section, there are three main options: the terrain width and length. If we adjust these settings, the terrain becomes larger or smaller. The terrain height is basically a range. It has a default value of 600. That means each vertex can be raised at most 600 units.
Uh-huh.
One thing to pay attention is that when we increase the size of the terrain, the resolution of the mesh remains unchanged. If we increase the width and length, the separation between the vertices will be increased as well, and the terrain mesh will be less detailed. Therefore, if we want to build a large terrain while maintaining the details, it is not a good option to adjust the width and length directly, but instead we should be using neighboring terrains.
Neighboring
First, we
terrains,
confirm
huh?
the settings. So the terrain is 1000 by 1000 in size. To create neighboring terrain, simply click on the first tab. And in the scene view, you will see 4 adjacent squares appearing next to our terrain. Simply click on a terrain and a neighboring tile will appear.
Ah. Wait, what? Oh, like, I get it. I get it. So it's this, and then you click that for neighboring. Like that. Oh, so then the resolution isn't stretched out. We have little sections, just sort of like a tile, but for your 3D environment. Okay.
And they are 2 separate terrain tiles with different terrain data.
Oh yeah, even over here it
If you
says.
want to build a large terrain, the recommended approach will be to create multiple neighboring terrains. So we can have a large terrain while the separation
Huh.
between vertices is unchanged. Now we will finally begin editing the shape of the terrain. But
This
first
is
I
what I
want to
do.
introduce a trick. Currently all the tiles are at the bottom. That means we cannot further lower the terrains. So what I would do usually is to use the set height feature. Down here at the set height controls section, I will just type in a height, for example 100, and hit flatten all.
Oh. Wait, where do you do that? Set height controls. Yeah,
At the set height controls section bottom. That means we cannot further lower the terrains. So what I would do usually is to use the set height feature. Down here at the set height controls section, I will just type in a height, for example 100, and hit flatten all. This will bring all the tiles upward by
okay.
100 units. We'll be able to lower the terrain. This is especially useful if you want to add water features like rivers, ocean, and ponds.
Yeah. Dude, what?
To raise the terrain, simply choose a brush that you want. Holding down the Control key while left clicking will lower the vertices.
Lower. Oh, well. Dude, it instantly brings it up to like this crazy amount. This is annoying. It's got a brush strength of 2, brush size of 300. Why is that a perfect circle though? That's so weird. Probably, let's see. Oh, yeah, because of that. Oh no. The hell? That's not it. Alright. You know what? This isn't gonna. This tutorial is. I need a better tutorial because this isn't gonna help. I'm just fooling around now. I think I should just work on my other projects. Until I find a better tutorial on how to do landscape action. Animated tiles we did this, we did this. Enemy attack state, we did that. Knockback effect, we did that. Melee attack, we did. Enemy damage, we did not do. Animation cooldown action RPG. Damage enemies action RPG. I don't know, we're reading farther than that. Stats and system. Coding, creating UI. Skill tree, skill tree, skill tree, skill tree. Ranged attack.
Hey everyone, it's Matt here with Nightrun Studio, and next up on the channel, we're going to be looking at how to equip and fire a bow in Unity. This one is going to be a two-part series. In the first video, we'll do all the functional stuff. We'll create arrows, spawn them into the game, and get them dealing damage. Then, in the second video, we'll make it look good, adding multi-directional animations, and adding the ability to swap between warrior and archer mode with a button press. The first video should drop next week, and if there's anything specific you'd like to see in this mini-series, be sure to let me know so I can try to add it in. I look forward to seeing you in that first video. Until then, this is Matt with Nightrun Studio. Cheers. Hey everyone, it's Matt here with Nightrun Studio, and in this video, we're going to get our hero firing arrows. I'm going to break this one into two parts.
First, I have to make sure my stuff works. I do want to make this animation faster. So what I need to do here, go to player. The cooldown time needs to be adjusted. Let me get this tile palette out of here. Player movements, facing direction, rigid body, knockback. I shouldn't need to touch that. Animator shouldn't need to touch that. Player health, player combat, cooldown, 0.25. I feel like that's a little better. It was way too slow before. We're gonna make we can make the game play maximized generally.
The first video will do all the functional stuff, and we'll actually get you set up with your bow and arrow. And the second video will be polish, including animations and that sort of thing. This video is part of my action RPG series, but if you're just joining us now, don't worry. The system is designed to be pretty adaptable and should work with whatever custom scripts you've got in your project. Let's get started. Now, first things first, we want to create our arrow. I'm using the Tiny Swords asset pack, and it comes with an arrow graphic, so I'm just going to grab that and drag it right into my hierarchy. This one, I'll just go to Scene View, double-click the arrow to zoom in on it, and I'm just going to move it over in front of my character. Let's add a rigid body 2D to give this some physics, and we're just going to take off the gravity so that it doesn't drop, which would look kind of funny in a four-directional.
Okay. So I'm gonna want to move Tiny Swords updates, effects, factions, resources, terrain. Effects, factions, knights, troops, archer, arrow. All right, obviously we need this to be, oops, with a layer. So if we add this, he doesn't add a layer to it. Defaults, untagged, sort, Gravity 0. We're gonna need it to have be above something. 5. Sorting layer. Just gonna put it at 5 for now.
Map. I'm also going to add a box collider to
Rigid body. Gravity 0. Rigid body. Box collider. Box collider. Automatically sets it up. Put a little music on. A little NES music.
arrow. That just gives the player the benefit of the doubt so that on a near miss, the player still gets the hit. I'm also just going to move the box forward a little so that the arrow can actually go into objects a little bit before it stops.
I can always adjust this later, but whatever.
With that done, we're ready to get coding. So I'm just going to go to my assets folder, into scripts, and head to my player scripts. I'll just right click, and I'm going to call this first one arrow. I'm going to begin by getting rid of the update method.
I was creating a script called arrow. Oh, I missed that part.
And head to my player scripts. I'll just right click.
Oh, I got it.
Call this first one arrow. I'm going to begin by getting rid of the update method as we're not going to be needing that one. And then we just need to make some variables. First off, we need a public reference to our rigid body. I'll call this RB. We're also going to need a vector2, which will be the direction the arrow fires. I'm going to start mine off as oriented to the right, since that's the direction my player is facing. Additionally, we'll need a public float, which will be the lifespan. I'm going to go with 2 seconds, though we can change this later in the inspector, as well as another public float for our speed.
Makes sense. No, we want a vector 2. I'll trust the process. I don't know why he wants to go right exactly. Well, why? Life spawn? Did he say span?
Is facing. Additionally, we'll need a public float, which will be the lifespan. I'm going to go with 2 seconds, though we can change.
Okay, yeah, he's typo.
Change this later in the inspector, as well as another public float for our speed. With all that set up,
Float
we can head
speed.
down to start, and all we want to do is give our arrow a push as soon as it comes into the game. To do this, we'll tell our rigid body that its new velocity should be equal to direction times speed. And here we're just drawing the direction and speed from our variables up top. We're also going to tell it that we want it to destroy itself, so we'll put destroy game object. But if we add a comma, we can then say how long we want it to wait before it does
Direction
this.
times
We just want it to wait
speed.
for its life.
Destroy. Oh, I got it. That's nice, actually. We gotta do linear velocity, don't we? Direction times speed. Then destroy objects. Destroy game objects. Then lifespan. I think that's what he's getting at.
That's all we need to be able to run our first test. So back in Unity, I'm just going to click on the arrow and add the arrow script. I'm going to make sure to drag my rigid body into the RB box, give it some speed. Let's start off by trying 3, which will be nice and slow so we can track it. Now when I get in the game, you'll see that it is in fact moving forward, and after 2 seconds it destroyed it.
Okay. Bow, dow, 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 dow. Give it a script. Speed. What is it? Speed 1. Throw the rigid body in. Oh yeah. Oh.
Itself. Now that we've got basic arrow functionality, I want to make it so we can actually shoot the arrow. I'm going to create a new script, and similar to the convention with basic arrow functionality, click on the arrow and add the arrow script. I'm going to make sure to drag my rigid body into the RB box, and my player new velocity. Hey everyone, it's Matt here with Nightrun Studio, and I'm just going to take my animation pane and dock it at the bottom of the sprite will be equal to our buried sprite. Next, we want to stop the arrow so that it doesn't keep moving. So we'll just tell it, hey everyone, it's Matt here with Nightrun Studio.
Don't hit the back
Just
button.
create an archer walk series, then you'll have a setup like this where certain along the information of the object we. Now then, down in our on collision enter method,
Wait, what the hell
we'll do
happened?
something very. Hey everyone, it's Matt here with Nightrun Studio, and in this final ranged attack video, we. Hey everyone, it's Matt here with Nightrun Studio, and in this final range. Hey everyone.
What
Hey
happened?
everyone, it's Matt here with Nightrun Studio, and in this video, we're gonna get our hero firing arrows. I'm gonna break this one into two parts. The first video method, which will just allow us to separate the different concerns of our code. Get started. Now, first things first, we want to create our.
I need to look to see what he
I'm
did
using
for the
the
rigid
Tiny
body. I
Source
know you
asset
can't see what
pack
I'm looking at, but
an arrow graphic. So I'm just going to grab that and drag it right into my hierarchy. This one, I'll just go to scene view, click the arrow to zoom in, and I'm just going to move it over in front of my character. Let's add a rigid body 2D to give this some physics, and we're just going to take off the gravity so that it doesn't drop, which would look kind of funny in a 4-directional map. I'm also going to add a box collider.
alright, so it doesn't do any of that. Okay.
The direction and speed from our variable. We've got basic arrow functionality. I want to make it so we can actually shoot the arrow. I'm going to create a new script, and similar to the convention we used for player_combat, we'll call this one player_bow. Before we start writing the script, let's set a couple things up ahead of time. I'm going to click on my player and add the player bow script.
Oh, we got to delete this. Player. Well. Alright, so player. We're gonna add the arrow script to the player. Is that what he wants to do?
Script. And I'm going to open them up, and similar to how we used
The player bow scripts. Okay.
an attack point earlier to determine the area where our attack would initiate, we're going to create an empty here, call it launch point, and this is the point at which the arrow will originate when firing. I'm just going to drag it out in front of my player a little bit so that.
Oh, okay, cool. We can do that.
That we don't have it bouncing into him. Now right off the bat, I'm going to get rid of my start method, and we're just going to add two variables. The first will be the transform we just created, the launch point.
Launch point, and
the
then
second
the
one is
arrow.
going to be a game object. We'll call this arrow prefab. This is just so we know what we're shooting.
Yeah, that makes sense. Probably gonna need to just add them to it, but what are we gonna do? We're gonna get the transform of the player, then activate.
Now, rather than put a bunch of logic in update, I'm actually going to create a shoot method, which will just allow us to separate the different concerns of our code and keep things more readable. So I'll just type in shoot here, and then down below we're going to create a public void method called shoot. I'm making this one public because later on we're going to need access to it from an external script. So in here we're going to, as soon as shoot is called, instantiate the arrow prefab. We want it to appear at the launch point's position. And finally, we don't need any special rotation at this point, so we're just going to put quaternion.identity, which will keep the arrow from rotating, and just put it in the game at 0. This brings us to another testable point, so let's click on the player. Make sure that his launch point is dragged into that box so he knows where to fire the arrow from. And finally, we just need to make a prefab. I have a folder here in my assets and just put it in the game.
Arrow prefab. It needs this position, and the identity, whatever the hell that is.
At 0. This brings us to another testable point, so let's click on the player. Make sure that his launch point is dragged into that box so he knows.
What? Launch point. We don't have an arrow prefab. I'm assuming we're gonna make that next.
And finally, we just need to make a prefab. I have a folder here in my assets called prefabs, and I'm just going to drag the arrow in there. With that done, we can delete arrow from our.
Does have a script on it. Rename this bad boy to just arrow. Arrow 0 is dumb. I feel like it might be safe to change the order. I can make a sorting layer too. I didn't even think of that. Player, enemy. Arrow. So if we take this back to 0, it disappears, but then if we give it the sorting layer and sorting layer, but well, that didn't work. Oh, that's layer though. That's not the same. Right. Okay, I think I screwed that up. Oh no. We're gonna put arrow here. See, this is default. So UI, that stuff stays the same. Okay, that should work. I can always mess around with that later.
Scene and just use the prefab. Let's.
Okay, we'll just drop this into prefab. We get rid of this. We go back to player. And we're gonna add arrow prefab to here.
Let's make sure to attach that to our player, and then we can have some fun. Now when we get in the game, it is go time. The arrows are deleting themselves after 2 seconds, but obviously we need some sort of a mechanism so this doesn't happen.
What was it? Let's try it out. Woo! It looks like they were still kind of behind. Why are they black? Fix that. Is that because it's a layer thing? Still. Okay. Rendering level. Okay, whatever. Fixed it.
So we definitely need to make it so we only fire on an actual button press. So before we get into our script, let's create that button. We're going to go to Edit, Project Settings, and then head over to our Input Manager. Here we're just going to open up our axes, and we need to pick a place to put our Shoot button. If you haven't yet used Fire 1, 2, or 3, I would recommend using one of those as the button you rename. I've already used those for other things, so I'm just going to click on Secondary Attack here, and I'm going to rename this one to Shoot.
Secondary attack. Is this not a thing? Attack, shoot. Oh, because it's... Fire 1, Fire 2, Fire 3, jump. So horizontal, vertical, interact, player swap. Oh, so he added a bunch of stuff in here that's just not here. Alright, we're gonna keep it at Fire 1. Well, I guess we'll call it shoot.
I'm going to make my character shoot with the J button. All right.
Left control. Yeah, maybe we don't want that. I guess we're gonna go into player combat scripts.
All right, so now we can head
Oh,
down to
no.
our update method, and before we
Oh, that's
send
true.
that
We
call
can-
to the shoot method, let's just add an if statement. In this case, let's
Shoot method. If inputs that get key dot get button down. I mean key code J technically.
check if there's an input, which is a get button down, and in this case, we're looking for the shoot button. Now, while we're here, let's also add some directionality. So let's head up top where we're going to make a vector 2 called aim direction. And again, I'm going to start off with vector 2 right, since that's the orientation of my arrow at the beginning. Before I pressed any button, I want it to shoot to the right. So now we just need to take in a direction that we're aiming at, and then pass that information along to the arrow so it can orient itself. I'm going to head down into Update, where we're going to handle aiming, and once again just make a separate method to keep our code nice and clean. This one can be a private void method called handle aiming. Now here we're going to do something similar to what we did in our movement script to get our direction presses for what way the player should move. We're going to make a local float called horizontal, which will just be based on an input, which is get axis raw, horizontal.
That.
Horizontal. So we'll store that value. We'll then do the same thing for vertical, storing it in this vertical float.
Okay. Why do I keep getting that T in there for some reason?
Now we're only going to want to store one of these directions if the player is actually moving, as when we stop pushing a button and those inputs are 0, we don't want him to reset his direction to a vector 2, 0, in which case the arrow would have no directionality at all. So we'll just make an if statement here, and if horizontal is not 0 or vertical is not 0, meaning we're pressing at least one of those buttons, then we'll take in our inputs. And in that case, we'll set our aim direction to be equal to a new vector, which will just be a mixture of the horizontal and vertical values. Now we're also going to normalize these. That just sets them to a magnitude of 1.
That makes sense. Horizontal, vertical, but then normalize it so it doesn't go weird when you're going diagonal. Yep. You got an else
Now we
condition?
just need to
Or...
pass this information along to the arrow itself. I'm going to come down into my shoot method, and before we instantiate, we're going to actually make a reference to our arrow script. We'll call that reference arrow, and it's going to be equal to the instantiated object.
Alright, let's switch these up.
The cool thing about this is it allows us to instantiate, but also store a reference to the object that we are instantiating. We do need to add a get component arrow at the end in order to fill that. Now we can just use that keyword arrow in order to send messages. So we're just going to go arrow dot, And over here, you can see in our arrow, we've got this direction variable. So we can just put dot direction is equal to
Aim direction.
Now, as soon as we instantiate the arrow, it will automatically get the direction that we are currently aiming. All right, make sure to save that, and now when we get in the game, we can shoot, and the arrow does in fact go in the direction that we're facing. Mine are a little slow, so my player's actually bumping into them after he shoots them, but you can kind of see that it's sort of working properly. All right, now before I forget, I'm going to just add a speed to this prefab of more like 8, so the next time I test, it moves a
Yeah, I got an idea. First off, this isn't correct. Oh, this is not supposed to be. Double check the script. Bam, bam.
So we can just put dot direction is equal to aim direction. Now, as soon as we instantiate the arrow, it will automatically get the direction that we are currently aiming. All right, make sure to save that, and now when we get in the game, we can shoot, and the arrow
Yeah. Not working. Ah, got some typos in here. Bam. Woo. Oh. Big bad. Starting layer. I thought I sorted that out. I don't know. Pew pew pew. Oh. Die. Die. Ooh. Alright, we're getting there.
Does in fact go in the direction that we're facing. Mine are a little slow, so my player's actually bumping into them after he shoots them, but you can kind of see that it's sort of working properly. Alright, now before I forget, I'm going to just add a speed to this prefab of more like 8, so the next time I test, it moves a little more reasonably. Then we can head back into our arrow script. Next up, I want to get our arrow rotating so it looks a little better in the game. To do this, we're going to go into Start, and right after we set its velocity, we're going to call a new method called Rotate Arrow. We then can create that private void method, and inside of here, we need to first of all calculate the angle to rotate. To do this, we'll make a float called angle, and we're going to use two formulas here. The first is a math function called atan2, and it will calculate in radians the angle that we need. Unfortunately, radians don't do us much good in terms of setting our rotations, so we then need to use a second math function called rad to degree, which will just turn it from radians into regular degrees. Now we can use those degrees to actually rotate our arrow. So we're just going to directly tell the arrow's transform that its rotation should be equal to, and here we're going to put quaternion dot Euler, and this just essentially allows us to input the degrees we just did and apply them to a rotation. So inside of the brackets now, we're going to make a new vector 3. As rotation, we need to access the z value, not just the x and y. Now we're not going to do anything to the x or y, so we can put zeros, and we'll just put our angle we just calculated on.
That is a wild. Rotation. Got the Euler. New vector 3. Zero. There you go. Interesting.
The Z. All right, with all that out of the way, we can now fire arrows in whatever direction we're facing. You'll notice when they come in, they are in fact facing the correct direction, and they're rotated appropriately. Of course, my player's still kind of bumping into them and twisting them around, which is causing some funny interactions, but it's working more or less. If you want at this point, you could go into your rigid body, and under constraints, we could freeze the Z rotation, which will just make it so that they don't spin around anymore. Though you might actually want this, as it's kind of fun to watch them ricochet into things, so I'll let you choose. As you can see, that change cleans things up pretty nicely, though of course we can spam the button. So let's add a cooldown.
I am going to freeze this scene, for sure.
Now in our player bow script, we're just going to create two variables. The first will be a private float. Actually, let's make that a public float called shoot cooldown. And I'm just going to start mine off at half a second. We'll then make a private float, this time I mean private, which will be our shoot timer, which will just keep track of the cooldown's current value. Down in our update method, we'll just make sure the shoot timer is always going down, so we'll subtract time.delta time. Then we'll just make sure that we can only shoot if we're pushing the shoot button, and if the shoot timer has in fact gotten to 0 or lower.
Get butt down, shoot. And oh, that's not right. Shoot cooldown is 0. Right. We're going with the shoot timers less than 0. Right. Shoot timers less than 0. Do this, and then probably after the shoots, we need to.
We can then come down
Oh,
to our.
go back up. Why is this repeating? Oh.
Just make sure that we can only shoot if we're pushing the shoot button and if the shoot timer has in fact gotten to 0 or lower. We can then come down to our shoot method and just make sure that after shooting, we set that shoot timer to equal the shoot cooldown, which will just reset.
Ah, that makes sense.
That cooldown. Alright, with that done, we've now got it so that we can spam the button all we want, but we only fire an arrow every half second. They're still a little slow, which is especially on the diagonal why that looks funny, but we're getting close. Alright, so the final thing we're going to do for this video is add some damage and knockback. Now, if you've not been following along with the entire series, the next part might be just a little different from you, though it is relatively universal. What we just need to do is find out where your enemy takes damage.
Oh no. I probably screwed up something. Double check. Equals cooldown. So we're going here, handle aiming. Whatever happened to shoot timers less than 0. Shoot. Sorry, I forgot to do the shoot timer. Shoot timer less than equal time that delta time. That would just keep subtracting it. Why would I want to do that?
Time.delta time. Then we'll just make sure that we can only shoot if we're pushing the shoot button and if the shoot timer has in fact gotten to 0.
Oh, because this is
lower. We can then come down to our shoot method and just make sure.
I don't know, let's just test it. That's just gonna keep going forever. Make this public so we can actually watch it. Do. Of course, I can't do that if I have the screen maximized, can I? Alright, so we're play focused. We're gonna go to player. Look over here for the arrow script. Yeah, it just keeps going. Like, is that okay? Gonna have to be.
That after shooting, we set that shoot timer to equal the shoot cooldown, which will just reset that. So we're going to make a public layer mask up at the top here called
Back it up.
Now, if you've not been following along with the entire series, the next part might be just a little different from you, though it is relatively universal. What we just need to do is find out where your enemy takes damage. In my case, that's in my enemy health script through this change health method, which just simply takes in an integer, which is how much damage it should be taking. I also have an enemy knockback script, which has this knockback method where I just pass along some information about the force and length of knockback and that sort of thing, and it then applies the knockback. If you want to, you can go back and check out those videos to see how exactly we've accomplished all of this. So the first thing we need to do here is actually recognize when we've hit an enemy. To do this, we're going to move away from a tag method, which is probably the most common, and use something that's just a little bit more performant, which is using layers. So we're going to make a public layer mask up at the top here called enemy layer, which will just allow us to pick whatever layers we want to be considered enemies and select them in the inspector. From here, we're going to create a...
Yeah, this is cool. I do like this method. That, also known as making a collision or collider. Collision box as a, as a trigger.
On collision enter 2D method, which will fire anytime the arrows hit any object.
So we need collision dot game object dot layer equals enemy layer.
Object with a collider. When they do that, we want to do a check to see if the object they've hit is of the layer that matches our enemy layer. To do this, we're just going to type enemy layer dot value, which will convert our enemy layer mask.
Ooh, that's even better. Oh, cause wait, what? I'm gonna go get ahead of myself here. Oh yeah, enemy layer. Right, because I made the max value equals enemy. Potentially.
We just made into binary
Equals
for easy
equals.
comparison. We'll then use a bitwise operator to
you're
do
getting
the same
fancy.
thing to our collision game objects layer. The one with the arrows is for shifting the 1 over in order to create binary. We can then quickly compare to see if the collision game objects layer overlaps with our enemy layer. If so, we'll run the next line of code. So if we do...
Holy crap, that's new. Enemy layer dot value. We did double. Paren on that. Enemy layer dot value. Bit operator. One collision dot game object dot layer. It's greater than 0. Wild. We're good.
Find that the object we've hit overlaps with our enemy layer, we want to deal some damage. So we're going to talk to the collision game object that we just hit, and we're going to look on it to see if it has an enemy health component. If it does, we're going to call that change health method. Now this is giving an error because it wants us to pass in how much health to change it by. And here I'm just
Enemy health script, which you do have that change health. Yeah. So this is arrow damage. Still want to probably make a variable for this.
put negative damage rather than giving a specific hard code.
Right. Negative damage. And up here, we're gonna want to make it a public floats or int.
Coded number, and that'll allow us to come up top and create a public integer variable called damage so that we can give the arrows different amounts for different arrows and reuse this script. Now knockback will work very similar to how we're dealing damage, except that it just needs a little more data. So let's pop into our enemy knockback script to see how we've set it up. Now this
So what are we gonna do? We're going to probably
This one is set up to take in information from our player's melee attack. So currently the transform it's expecting is the player's transform, so that it can tell what direction to be knocked back. In this case, we want it to work for the player or the arrow, so let's just change it to force transform, which is just a more logical name, as it's the object exerting force on our enemy.
force transform. Okay.
Now the way this knockback method works is that it takes in our force transform in order to calculate the direction that it needs to travel. It also runs things like our stun and the amount of time that the knockback lasts.
Yeah.
So to call this, let's head into our arrow script. We're just going to go collision game object. We're going to look for the enemy knockback component. If it has it, we'll call knockback. And now at this point, we just want to pass in the transform of our arrow, so we can type transform. Now we just need to create some variables so we know how powerful this arrow is.
Enemy knockback, right? Oh, no, we're calling that's. Oh yeah. Okay. Yeah. Then we're calling knockback. Transform dot. We also need knockback force. We need all this. Wait, were they floats? Float, float, float.
arrow, so we can type transform. Now we just need to create some variables so we know how powerful this arrow is. Let's create a public float called knockback force, how hard to hit the enemy. Another public float called knockback time, which is how long he will be in motion before he snaps to a stop. And finally, a public float called stun time, which is how long he'll be dazed at the end of the knockback. Then we can just come back into our onCollision method and just add in those 3 pieces of information. Now back in Unity, we're going to need to click.
They're gonna be mad at me for using parentheses or commas on it. It should be happy. Happy little code.
Click on our enemy and make sure that he's actually on the enemy layer. We can click on layer here, and if you don't,
Yeah, they should all have that layer. Yep.
already have an enemy layer, be sure to add layer, put in one for enemy, and then make sure that you apply that to all of your enemies. I've actually got a bunch here in my enemies drop down, and I'm just going to shift click them all and set them all to be on the enemy layer. Next, I'm going to open up my arrow prefab by double clicking it. Make sure that it knows that the enemy layer includes enemies. Later on you can add other things if there's a other things your player
If I didn't need an arrow layer,
deal damage to.
I got confused by
I'm just
that.
gonna give it 2 damage for now. Let's give it a knockback force of 10. I'm gonna make my
But none of this. Did I forget to save? I forgot to make it public. Whoops.
knockback last for about half a second, and we'll just make this stuff
10.5, 1. 10.5, 1. Okay.
Let's click this arrow here to get out of the prefab. Now when we get in the game, we can fire arrows at will, and they will in fact send the enemy flying backwards. And if we hit him enough times, he will take enough damage that he's destroyed.
That's way too much
For the most
knockback.
part, that's
That's way too much knockback. Need to chill out on that. Ooh. Ooh. Not doing damage though. Something ain't right. Stop doing damage. Let me look at the arrow prefab. Oh yeah, damage 0. That would be why. Choo. Boom. Oh. Boom. 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 Dead. It should just, when it hits something, disappear or something. But once it touches something, it just kind of... that's kind of an easy fix.
It's working well. Obviously, we've got some problems with floaty arrows that we would rather see them get buried in the object that they're hitting. And we've also got some work to do in terms of adding animations to our player, as well as this strange offset where when we fire, the bullets kind of seem to jerk a little bit away from the player and not quite fire straight on. We'll get to all that in the next video where we do some polish. I hope to see you in that one. Until then, this is Matt with Nightrun Studio. Cheers. Hey everyone, it's Matt here with Nightrun Studio, and in this final ranged attack video, we've got a whole lot going on. We're going to make it so you can toggle between archer and night mode with a button press. We're going to animate in 8 directions for firing the bow, make it so the player actually stops when shooting, and fix a number of other little bugs. This is probably the longest video I've ever made, so let's just get right into it. So the first thing we're going to do is make it so that this arrow...
Alright, that's kind of a lot of work. It's already 9 o'clock. So we're going to go ahead and submit this to... Bam, 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 bam. Oh, first off, let's save. Why is that not? Because I'm not here. There we go. Save. Make sure this is all saved. Yep. Arrow functional. Next is arrow fixing. Arrow fixing. Animations for archer. Second. Okay, that will do it for tonight's stream. Hopefully you're catching the vibe and have anybody chime in tonight. But I will be on again tomorrow night doing some more. Have a great night. See you next time.